All right, so we are here to talk about activators and inhibitors and cofactors. And so the first thing says, I can explain how cofactors can affect enzyme function. Cofactors help enzymes, and the way they do that is let's see, we'll put them up here. They're going to encourage the enzymes and substrates to come together. So they're kind of like matchmakers. They help find the substrate and the enzyme and literally bring them physically together so that they can do their job. It's kind of like if you have a coworker at work that helps you do your job. You can work faster. The second says, I can explain why enzymes need to be regulated. Well, enzymes are great when we need them to work. They help these chemical reactions occur, all that good stuff. But think about digestion and all of the enzymes involved in digestion. If you are not digesting food, if you don't have any food in your stomach, you don't want to be using those enzymes because then you're going to start digesting yourself. So while enzymes are great and we need them, we only need them to work at certain times. And so we need to be able to turn them on and off, which is what it means to say that they're regulated, so that we only have them acting when we need them to be acting. The next one says, I can explain how activators can affect enzyme function. Activators are going to bind to one of two places. And an activator can bind to the active site. This is called cooperativity. Oops, I spelled that wrong. Cooperativity, because they're cooperating, because what happens is you have these enzymes here and they're kind of, I don't want to say hooked together, but kind of hooked together. And when a substrate binds to one, or an activator binds to, usually it's a substrate, binds to one, it freezes these other three into the active state, which makes it really easy for substrates to come bind to all of them. And so by turning on one, and sometimes this might be one enzyme with 4 active sites, it just really depends. But by that one binding and causing that, that freezing of the enzyme in the active state, it allows the others to bind more easily. So it's going to speed up the reaction. Okay, so it activates, turns on the enzyme, you could say, like a light switch, and that speeds up reaction. If you saw this in a graph, what you would probably see is a normal enzyme and then with an activator. Okay, so this is time, this is product formed. Okay, so basically you're going to see more product formed faster with the activator. The other place it can bind is an other site, and we call that allosteric. Allo means different, stare means conformation or location, shape. So a different place or a different location. And what we see now is, let's say that this is the enzyme. Let's say this is the substrate. And what we'll see is this activator come and bind to a different site, not the active site. And when it does that, it causes the enzyme, this is the enzyme. Let me have that activator bound back here. So when the activator binds, it causes the enzyme to go through a conformational change, and now that substrate can come in and bind. And so it freezes that enzyme in that in that active state, but it does it allosterically, which means it does it by binding to a different site besides the active site. The next says, I can explain how inhibitors can affect enzyme function. An inhibitor is going to inhibit. It's going to turn the enzyme off. Again, it can bind either to the active site, which we call a competitive inhibitor, because it's literally going to compete. So let's say that this is, those aren't very good, but anyway, enzyme and substrate, okay? And what you see, let's do the inhibitors in a different color. You see this inhibitor come in and bind and literally gets in the way of the substrate binding. So it physically blocks the binding. That would be a competitive inhibitor. What you're going to see with this graph, if this is the normal enzyme, you're going to see it it could just slow it down, or it could literally completely flatline. So it could stop it altogether. It could shut it down completely, in which case your line would go to 0. Okay, so competitive tend to be more this, non-competitive tend to be more like this. So competitive don't tend to shut it down as badly as non-competitive. So the other, just like with activators, is an allosteric inhibitor. We call this the non-competitive. Because what it's going to do is, if this is the, substrate and enzyme, okay, it is going to come in and bind somewhere back here, just like the activator. And when it does that, let's see, there we go, causes the enzyme, there's a substrate, it causes the enzyme's active site to change, and so it can no longer accept that substrate. So it stops the enzyme from working, but it does it by binding somewhere other than the active site. All right, so I can explain how cofactors, we talked about that. I can explain why enzymes need to be regulated. We talked about that. I can explain how activators affect enzyme function. So we talked about that. They speed up reactions. I can explain how inhibitors can affect enzyme function. So they slow down or stop the reaction by either blocking the active site or causing a change in the active site so the substrate can no longer bind. I can define allosteric. Allosteric just means somewhere other than the active site. So these are both allosteric because they're binding another part of the enzyme. And then I can compare competitive and non-competitive inhibitors. We didn't really do that. Competitive and non-competitive inhibitors are both going to slow down or turn off the enzyme. So that's how they're similar. That's how you would compare them. They're both inhibiting. And then I can contrast them. Let me zoom out a little bit so you can see all of that. I can contrast them would be that the competitive binds to the active site and physically blocks the substrate, while the non-competitive binds somewhere else and just prevents the substrate from binding. So that is cofactors, activators, and inhibitors, and how they can affect enzyme function, and I hope that helps.